Alright, ladies and gentlemen, so in this video we're going to be diving on into the piecewise function. So we have a quick little goal for today, and that's to do a quick kind of reminder and definition of what a piecewise function is, and to analyze it a little bit more so in a real world scenario as well. And then we're going to take a look at some graphs in addition as well. So don't forget, a piecewise function is defined by two or more equations over a specified domain. These equations will each have a specific domain that they are dealing with, and it shows a shift, or it shows a change in the domains as we change on through. So let's take a look here. The goal of this first example is to graph the piecewise function, understanding what we're going to be dealing on with. And so let's take a look first and foremost. So for every x value that is less than or equal to positive 1, we're going to be using the value or the equation 2x plus 3. So let's take a look. Let's do a quick little graph. And let's go ahead and say 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, and 5. So we know everything less than positive 1 is going, less than or equal to positive 1, is going to end up with 2x plus 3. So what I want to do first and foremost is I want to find out what is the output, or what is the y value when x does in fact equal a positive 1. So when 2 times 1 plus 3, we get a value of 5 here. So we know at 1, the value is going to be a positive 5. And because it's a linear function, we also know the y-intercept of this line is going to be at a positive 3. And then we have a slope in this case of positive 2. So I'm going to go down 1, 2, and then over 1, just to kind of make one more line on in there. So let's go ahead and just kind of connect this line, the best of our abilities here, and comes on out somewhere as it continues down into negative infinity. All right, and so now what about negative x plus 4? Well, the goal is to see, hey, where is the graph negative x plus 4? Well, the graph is negative x plus 4 for everything greater than positive 1. For everything greater than positive 1, we are going to go ahead and include the graph negative x plus 4. Because we've already included 1 for the first function, 2x plus 3, we're not going to include it again for negative x plus 4. But I also do want to find out where is the output value at positive 1, so I know where to start the whole of my graph. So negative 1 plus 4 gives us 3. So at 3, we are now going to have a hole in that graph. All right, and so let's continue to kind of see where this particular function is going to go. Well, we have a negative slope, so we're going to go down 1 over 1, and then we're going to go down 1 over 1 once again. And that will continue that pattern on off to positive infinity for those x values in there. And so that's what a graph of our piecewise function would look like. Remember, we closed off the circle in the 2x plus 3 because it was the or equal to, and then we decided to go ahead and to leave it open for the second part of our function in there. So there's a quick little reminder of the piecewise functions. All right, what I want to go ahead and do is kind of put a wrap up on the last two videos that we had. The last two videos we had about the step function and the piecewise function. I want to give you an opportunity to answer this question on your own and think about how we can utilize some of these step functions or the greatest integer function and the piecewise functions in some more real life scenarios. So give this one a shot on your own. We'll go over it first thing, and then we're on to the next one.